as she said, my name is Leyon. I've been involved in Linux and open source software for nearly 20 years now. I started using Linux approximately 15 years ago, and I use it as my daily operating system at home and at work. But I have been using Unix and open source tools since a little bit before then. As Janie mentioned, when I was at university, we had some small microcomputers in the computer science department, and they were running versions of Unix that the vendor had supplied. And some of the tools that they had weren't really quite up to snuff, or they had bugs and didn't work, or they crashed. So what we would do is download a lot of these open source programs off of the internet and install them locally, and it just made the environment much nicer. So now the open source movement is starting to expand and take over the computing world. And I'm going to tell you a little bit about what it is, how it came to be, and just tell you that I think it's going to be growing since then. So what exactly is open source? In the context of computing, it is basically a development methodology and a license. It involves having, one of the main components involves having access to the source code, which means that you're able to examine how a program works, make changes, make it better, and run it on your own. It involves collaborative development. Because you publish the source code, other people are free to look at the way the program is constructed, make their own changes, and maybe send them back to the original author to be incorporated in the next version. It has a global audience, because usually these sorts of programs are published on the internet. Anyone in the world can access them, download them, and see them for themselves. And often it has free or low cost. It's not necessarily a requirement that it be free. You are allowed to charge for distribution if you want to, but in most cases it actually does turn out to be free, simply because of the licensing clauses that cover the distribution of it. So how did this all come to be? Well, back in the really early days of computing, and I'm talking about in the 50s and 60s, the hardware was terribly expensive. It would cost millions of dollars to purchase a computer, and large institutions would lease them from companies like IBM or Univac or other places like that for tens, maybe hundreds of thousands of dollars a month. And if you're paying that much for your computing, you expect to have some programs that will run on them. So the vendors would often supply a Fortran compiler or a statistics package or something like that. And these were really thrown in kind of as an afterthought. You're paying so much for the hardware, here, have some software too to run it. But that's not really the practice anymore. It used to be that you would get the source code either supplied with the machine or available in printouts or microfiche. I personally have seen the microfiche cards with the source code to DEX VMS operating system and all of the libraries and utilities that go along with that. But I don't think you can get those anymore. So with all of the source code being available, there grew up around these institutions, especially universities, a culture of people who were interested in computers and how they worked. And they developed the term hacker. Now the press these days calls hackers, criminals and people who break into machines and do illegal things. But in the old days, a hacker was really a badge of honor. It meant someone who was knowledgeable about how a computer worked and someone you could go to for answers. So they had this culture that developed around shared computing resources. And the culture included open access to information. At MIT in the 60s and 70s, you could just walk up to a computer terminal and log on to the system. You didn't need to have a password or even an account. You could just log in and access the computer resources and do your work and then go back. There were no protections built into the system, so anyone could see anybody's files. And sometimes somebody would go in and delete a file that he shouldn't. Well, then it had to be restored. But that was the price you paid for having an open system. They also developed the practice of sharing the code through early networking. the ARPANET, for example, is a network that a lot of academic institutions were connected to. It turned into the internet later on. There were other professional organizations that also facilitated the sharing. Digital Equipment had a users group called DECUS. IBM has a users group called Share. Unix users have an association called Usenix. And these are places where people can come together, share ideas, share code, see what people are working on, and have a real community form around these systems. Code would be shared via libraries, mag tapes, and on the network. I mentioned Usenix. That was a group dedicated to Unix users. And Unix had been developed by AT&T in the late 60s and early 70s, but they were prohibited by a consent decree with the government from actually selling computer software or hardware. So what they did was they simply made their Unix software available to people who wanted to license the code for a nominal charge, but also with the proviso that there was no support provided. And so people who had Unix at their academic computer center were really on their own. So they formed this group of other people for support. And so that also accelerated the hacker culture and the interconnections between the people who participated in it. Also on early microcomputers, the very early machines you constructed yourself. You didn't have Microsoft Windows or Word or anything that came along with it. You would toggle in certain instructions into the computer's memory every time it booted. And if you wanted to run a program, you had to code in each machine instruction or load it from some sort of paper tape. But it was all very primitive, and there were no files. You just basically turned the thing on, it ran, and you got your answer. That started to become more sophisticated with the growing user base in microcomputers. And companies like Microsoft, for example, developed to begin to create software for that burgeoning market. Bill Gates wrote a very famous letter. He had gone to a computer club out in California, and he was in the process of developing one of his early basic compilers for a machine called the Altair. And depending on who you talk to, he either lost the tape or he deliberately left it there to be found, or else it was stolen. But in any case, a few months later, after this computer club meeting, the source code to the Altair basic compiler was distributed among the user community. And he wrote a famous letter basically to some magazines and said, basically, the majority of you hobbyists must be aware that most of you steal your software. Hardware must be paid for, but software is something to share. Who cares if the people who work on it are getting paid? So even at that early stage, the dichotomy between the proprietary software vendors and the free software open source people was becoming more marked. Also, the companies were not distributing their source code with their hardware any longer. They would provide it under a restrictive license or a non-disclosure agreement, or they would put it under some copyright terms so that you weren't allowed to do anything with it. So by the late 70s and the early 80s, a lot of this software was becoming more and more difficult to acquire. Now at this point I want to take a little diversion because open source, one of the big components of open source is the licensing agreements. So I wanted to talk about the dreaded term intellectual property, which if you're a lawyer you probably just cringe because intellectual property is not a very specific term. There are things like trademarks and trade secrets. That doesn't really apply to software very much. There are patents, which covers an idea, and for many years it was assumed that software could not be patented. But in the middle 80s, the US Patent Office started to grant patents on software and business methods, and that's still a very controversial thing. It's not necessarily settled law. But open source is not really concerned with patents too much. Really, what protects most programs written these days is copyright. And one of the big watershed events in copyright was the US Copyright Act of 1976. Before that time, if you wanted to copyright any work, you had to send in a copy to the US Registrar of Copyrights, along with a nominal fee. It really wasn't that an egregious requirement, but it did prevent a lot of people from just casually copyrighting some program they wrote the other day. Now, after 1976, programs and any creative work is assumed to be under copyright. All you have to do is put a little note on the top. In fact, sometimes not even that. It's simply assumed to be under copyright unless you explicitly disclaim the copyright. And that has made it a lot easier to apply a copyright to a program that you write. And we'll see that that becomes important later on when we talk about open source licensing. The other possibility, of course, with intellectual property is the public domain, which is a concept enshrined in law. But what it basically means is that there is no owner of this work. And so even though you own it, you wrote it, you can explicitly disclaim ownership. And that will make the work a freely available work to whoever else wants to come along and pick it up. But that also means that that other person can then apply a copyright to his version of it. He can't affect your original public domain version, but there is the possibility that someone could take your work, make improvements on it, and then not share it with you, sell it, and anything like that. So public domain, it's used rarely, but it's really not that prevalent in the open source world. So where are we now? We're going to talk about a couple of big events in the history of open source. Before the term open source came along, there was another fellow by the name of Richard Stallman. He worked at the MIT Artificial Intelligence Laboratory in the 70s and 80s. And he was a hacker from the old school. He wrote in Lisp, he did artificial intelligence work, and he was really still is an excellent programmer. What happened was, in 1980, they got a new Xerox laser printer. And this laser printer had an annoying feature. The other printers in the lab could tell when it was out of paper and send a little message to the operator saying, hey, I'm out of paper, please put some more in. But for some reason, the Xerox couldn't do that. So Richard asked Xerox if he could have the source code to the laser printer's firmware so that he could add this new feature and make it compatible with all the other printers in the lab. Xerox said no. Xerox said, our source code is copyrighted and you can't have it. Well, that made him really angry. And just like the Hulk, you wouldn't like him when he's angry. He thought this was a real slap in the face to everybody who bought Xerox products. So he decided that he was going to create an entire software ecosystem that would be freely available. And there wouldn't be any corporation lurking in the background saying, no, you can't have this. He was going to make his software freely available. And he called it his operating system GNU. And I'm not going to go into very much of that. But he announced it in 1983. And by 1984, he had quit his job at the AI lab. And in 1985, he published what he called the GNU Manifesto. And in it, he laid out a vision for how he wanted his software to be brought into the world and take over. He conceived of free software as being about freedom, not free as in price, but free as in terms of liberty. So think, the famous saying is, think of free speech, not free beer. So he came up with several criteria by which a program could be judged to be free software. The first freedom would be that you would be able to run the program for any purpose. There would be no restrictions on how you could use the program. The second freedom would be that you would have to be able to study how the program works and change it so it works as you want it to. Access to the source code is a precondition for this. Third freedom is the freedom to redistribute copies so that you can help your neighbor. He envisioned this free software as a social good. And finally, you have to have the freedom to distribute copies of your modified versions to others. By doing this, you can give the whole community a chance to benefit from your changes. Access to the source code is also a precondition for this. So how would he go about implementing his vision for distributing free software? Well, he came up with the concept of what he called a copyleft, which is similar to a copyright, except it's a copyleft. And he created something called the General Public License, which all of the GNU software programs use. It is a license. It is not a contract. So it's not something that you and he get in a room and you both sign like that. There's no consideration, et cetera, et cetera. So it is a license that the GNU people grant to you. So what they do is they start with a copyright so that they retain the ownership of the software, but then they add additional terms that will explicitly allow distribution to other people to use, modify, and redistribute the code, or from any code derived from it. The concept of derivative work is one that is in copyright law. So if you modify a GPL program, the derived work is also a GPL program. Now this doesn't necessarily, just because you can redistribute the software and get it, doesn't mean that you can't attempt to sell it. For many years, Richard made a living selling GNU software on magtape before the internet was so prevalent and you could just download megabytes in a flash of an eye. The best way to get a large collection of software was to get a magtape that he would cut up in Massachusetts, and he'd send it out to you in the mail. But he would charge you for this. It cost him time and effort, and there were some materials involved. And if you made a little profit doing it, that's fine. But once you received the software, you were then free to redistribute it to anyone who asked you for it. So he's using copyright and additional licensing terms to preserve your freedom, well, the freedom of the software. No one's going to come after you if you download a copy of, say, Linux, which is an operating system, under the GPL. No one's going to come after you if you're using a copy of it, because you presumably received it from somebody who had permission to distribute it. But let's say you want to add some code and make some modifications. Maybe you want to add in some proprietary logic that will do something that you want to keep to yourself. Well, what happens? You are allowed to use the code as you want to internally, but are you allowed to redistribute it? Well, no, the answer is that you can't really do that unless you distribute the source code for the proprietary bits that you wrote. So a lot of people don't necessarily want to do that. If you do distribute the code without the GPL license covering your works, then you were contravening the original license terms to begin with. Since you then basically reject the license that you were given, the only thing that you have to fall back on that still covers the original work that you received is the original copyright, which does not allow for redistribution. So you're kind of in a bind that way with GPL software. Some people consider this to be a viral condition, in that once you have GPL software, if you make any modifications, then your modifications also have to be GPL'd. Maybe it is, maybe it isn't. The original author might say that he's simply preserving the freedom of the original program, but you may not see it that way. But of course, you're free to not use GPL software either. So anyway, Stallman considers proprietary code, which is that which does not respect his four freedoms, to be unethical and antisocial. That's why he developed the GPL and free software to be a catalyst for social good. But not everybody is interested in highfalutin ethics or bettering the world through open source software. Well, free software, I should be clear about that. There was a company called Netscape. You may have heard of them. Back in the 90s, they used to have a browser. They decided in 1998 that they were having their lunch handed to them by Microsoft and their Internet Explorer browser. So they decided to do something radical. They had read a paper by a fellow named Eric Raymond called The Cathedral and the Bazaar. And in it, Eric contrasted what he called the cathedral, which was the proprietary model of software development, where the priests go off to their tower and do their coding and come back in a month or a year or whatever with the next version, and that's handed to the users and that's it. He contrasted that with the bazaar model, not the bizarre, but the bazaar, where it's a much more chaotic development environment. You have lots of people working on things, developing new routines here and adding new code, and if it works, it's great, it's added. If it doesn't, it kind of dies off and gets deleted. It's a much more organic development model. And Eric Raymond's premise was that this bazaar development method was actually more practical. And so Netscape decided to release their source code, and they were influenced by the Cathedral and the Bazaar paper, and they wanted to release it under some terms that would still preserve their rights, but would still allow the world to see the code and hopefully develop it and make it better. They announced that they were going to release their code on January 22nd, 1998. And 12 days later, a group of people, including Eric Raymond and others, met to have a brainstorming session, strategy session. And they came up with the term of open source. And this was separate from the earlier term of free software. Open source would be business friendly. Open source would not be really concerned with ethics. Open source would be a business case that you could take to a manager and have him approve it, and he would understand it. So the next day, after they announced their new creation, another fellow named Linus Torvalds decided that open source was good. And he had a kernel called Linux that I mentioned that I use earlier in the talk. Then the very next day, he announced that he was behind open source. Other people came on the bandwagon. Eric Raymond published another paper, and at the end of the month, they formed a group. I don't know if it's a corporation or not, but a group called the Open Source Initiative that would analyze software licenses and determine if they should be allowed to use the term open source or not, which they retained as a trademark. They would do this by applying a set of criteria, similar to Stallman's free software criteria, but this is much more business-oriented. So I have them here, but I'm not, and I'm going to just go over them quickly. The first criteria is that the license must allow free redistribution. You are not allowed to restrict any party from selling or giving away the software as a component of an aggregate software distribution containing programs from several different sources. This license shall not require a royalty or other fee. The program must include the source code and must allow distribution of source code as well as the compiled form of the program. The license must allow modification and allow creation of derived works. There are other criteria: integrity of the author's source code. The author is allowed to say, you can't change my code, but you can take my code and you can also have these other changes that you can apply on top of it. That's called a patch. So you're allowed to keep the source code pristine as originally written, but then have patches that you write which apply on top of it. You're not allowed to discriminate against persons or groups. You're not allowed to discriminate against various fields of endeavors. So for example, you can't say, you're not allowed to use this program for genetic testing. You're not allowed to use this for running a nuclear power plant, things like that. The rights attached to the program must apply to all to whom the program is redistributed. without the need for execution of an additional license. So everything has to be included and self-contained. You can't come back and say, ah, there are more. License cannot be specific to a product, and it must not restrict other software. And it must be technology neutral. And so you can clearly see that the definition of open source is much more legalistic than it is moralistic. Now, there are other sorts of open source software. The GPL is an early case, and it is an open source license. You may come across other licenses. For example, there's something called the BSD license, which covers software which was written by the University of California at Berkeley, BSD, Berkeley Software Distribution. That is also an open source license, but it is not a copyleft license. Copyleft means that any derived works must also be redistributed under the original terms. A BSD license provides access to the source code, but you're allowed to then take it proprietary and turn it into a non-BSD licensed product, as long as you retain the copyright of the BSD original time, the original. So anyway, to wrap up, I wanted to say that the success of free software and open source software is undeniable. A decade after the formation of the term open source, Richard Stallman's GNU software, combined with Linus Torvalds' Linux kernel, are easily the second most popular operating system in the entire world today. Even Apple has taken a free software operating system and used it as the basis for their popular OS X, which powers the current crop of Mac computers. OSS in the form of Android is quickly becoming the #1 platform in the world on mobile phones and mobile computing. And in the realm of supercomputing and clustering, Linux is overwhelmingly prevalent. As time goes by, the proprietary software vendors are discovering they cannot compete with the millions of users reviewing and refining the source code that comprise free software. As hardware prices drop, the percentage of a computer system's price devoted to software is continually rising, and the proprietary vendors are discovering that it's hard to compete with free and open. For all these reasons, the future of free and open source software is very bright indeed. You're not allowed to discriminate against various fields of endeavors. So for example, you can't say, you're not allowed to use this program for genetic testing. You're not allowed to use this for running a nuclear power plant, things like that. The rights attached to the program must apply to all to whom the program is redistributed, without the need for execution of an additional license. So everything has to be included and self-contained. You can't come back and say, there are more. License cannot be specific to a product, and it must not restrict other software. And it must be technology neutral. And so you can clearly see that the definition of open source is much more legalistic than it is moralistic. Now there are other sorts of open source software. The GPL is an early case, and it is an open source license. You may come across other licenses. For example, there's something called the BSD license, which covers software which was written by the University of California at Berkeley, BSD, Berkeley Software Distribution. That is also an open source license, but it is not a copyleft license. Copyleft means that any derived works must also be redistributed under the original terms. A BSD license provides access to the source code, but you're allowed to then take it proprietary and turn it into a non-BSD licensed product, as long as you retain the copyright of the BSD original time, the original. So anyway, to wrap up, I wanted to say that the success of free software and open source software is undeniable. A decade after the formation of the term open source, Richard Stallman's GNU software, combined with Linus Torvalds' Linux kernel, are easily the second most popular operating system in the entire world today. Even Apple has taken a free software operating system and used it as the basis for their popular OS X, which powers the current crop of Mac computers. OSS in the form of Android is quickly becoming the #1 platform in the world on mobile phones and mobile computing. And in the realm of supercomputing and clustering, Linux is overwhelmingly prevalent. As time goes by, the proprietary software vendors are discovering they cannot compete with the millions of users reviewing and refining the source code that comprise free software. As hardware prices drop, the percentage of a computer system's price devoted to software is continually rising, and the proprietary vendors are discovering that it's hard to compete with free and open. For all these reasons, the future of free and open source software is very bright indeed. Thank you very much.